Hi everybody, this is a video on absolute value equations. It is late and you can probably hear my dishwasher in the background, so sorry for not getting this done a little bit earlier, but hey, absolute value equations are absolute value equations. Guess I need an S. We look at number 1. If I want to find the absolute value of x plus 5 is equal to 12. There are two equations that we are going to have. One is going to be the exact same equation that we started with. So x plus 5 is equal to 12. We can subtract 5 from both sides and get a value of 7 for x. If we check this, that's going to say that the absolute value of x plus 5 is equal to 12. And if I plug in a 7, the absolute value of 7 plus 5 is 12, because the absolute value of 12 is 12. So this one checks. I know you all can probably plug it in there a little bit faster and check, but I want everybody to see where that checking, how the checking should look. One of them is the positive, the other one is the opposite of x plus 5 is equal to 12. So the opposite of x plus 5 equals 12. We have to use the distributive property. Negative x minus 5 equals 12. We're going to add 5 to both sides, and we get negative x equals 17. We divide both sides by negative 1, and so x will equal negative 17. If we go back up here and plug in the absolute value of negative 17 plus 5, negative 17 plus 5 is negative 12, and we know that the absolute value of negative 12 is 12. So it checks. Notice that I split the two equations because the absolute value is isolated. As long as the absolute value bars are isolated, then you may split it into the two equations and find your answers. Problem number 2 has a 4 in the front of the absolute value bars. So here's my absolute value of x minus 6, and then it is equal to 16. I can't find two equations yet because I don't have my absolute value bars isolated. And we cannot distribute to absolute value. We treat it almost like a variable itself. So to isolate that absolute value, we have to divide both sides by 4. This gives me x minus 4 equals 4. At this point, I can find my two equations. X plus 6 equals 4. Pardon me. X minus 6 equals 4, where we add 6 to both sides, and we get 6, or x equal to 10. If we plug that back in, 10 minus 6 is 4. Absolute value of 4 is 4, and 4 times 4 gives me 16. So I'm good. The other one is the opposite of x minus 6 is equal to 4. So negative x plus 6 equals 4. We subtract 6 from both sides, and negative x equals negative 2. We divide both sides by negative 1, and so we get x equal to 2. We said x equals 10 works, but let's see what happens if I plug in a 2 up here. Well, 2 minus 6 gives me negative 4. But because it's the absolute value, I can actually take the absolute value of that -4 and it becomes 4. And 4 times 4 gives me 16. So I'm good. Problem number 3 is the absolute value of 3x plus 7 is equal to -15. Now, I could be really mean and I could make you work all this out, and some of you could go ahead and work this out. Look what happens. If you have 3x plus 7 equals -15, you subtract 7 and get 3x equal to -22, and divide both sides by 3, you get -22 thirds. You still, if you plug this in, you get the absolute value of -15, but the absolute value of -15 is not -15. The absolute value of -15 is +15. This cannot work. Does not work. Even if you do the opposite, it is no solution. It is no solution. So if you've got your absolute value bars isolated and it is equal to a negative, then it is no solution. Please make the note to yourself that the absolute value bars must be isolated before you determine if it's no solution or not. Problem number 4 is the absolute value of b plus 5 is equal to 2b minus 9. We have two equations. The absolute value is isolated, so one of my equations is going to be b plus 5 is equal to 2b minus 9. And the other one is going to be the opposite of b plus 5 is equal to 2b minus 9. If you remember, you've got to check, especially on these types of problems. We subtract -2b and we get -b plus 5 equals -9. We subtract -5 from both sides. We get -14. When we divide by -1, we get b equal to 14. Oh, we don't know. We got to check it. 14 plus 5 is 19. An absolute value of 19 is 19. 2 times 14 is 28, and 28 minus 9, that actually does work. So b equals 14 is the correct answer. If we have -b minus 5 equals 2b minus 9, and we subtract 2b, that gives us -3b minus 5 equals -9. We add 5 to both sides. -3b is equal to -4. And so a negative divided by a negative is a positive 4/3. Well, if we plug in 4/3 here to our 5, 4/3 plus 5, and the absolute value of it, 4/3 is a repeating decimal, so the whole decimal thing isn't going to work real well. But this is 1 1/3, so it would actually be 6 1/3, because this is 1 1/3. Over here, we would have that equal to 2 times 4/3, or 8/3. 2 times 1/3, or if you wanted to multiply it by this way, it would be 2 2/3 minus 9. Well, that's a negative. That's going to be a -6 1/3. Are they equal? No. So this answer doesn't work. Remember we said you had to be very careful if there was a variable inside the absolute value and a variable on the outside. You should be able to simplify in your calculator if you're not loving the math. Things to remember about absolute value equations. One equation is exactly the same. The other equation is the opposite of what's inside the absolute value. We have to distribute a negative. Come and see me if you still have questions. Have a good night.